Alright guys, today we're on page 498 and we're talking about mutually exclusive events, okay? So our lesson today is we're just going to be figuring out what that means and how we identify it. I'm going to read kind of a little bit of the paragraph. You should read over it yourself. It says, some probability problems have the likelihood of more than one outcome, and that is called compound probability. It says, in this calculation of probabilities involving multiple outcomes, one example of a compound probability situation is a single attempt that has the possibility of several successful outcomes. Okay, so what we're doing is we are deciding today how to recognize something, whether or not it's mutually exclusive or not. So I'm going to kind of read the example of, or kind of let you know what mutually exclusive is. It says, for example, using a bag of marbles containing 4 red marbles, 3 blue marbles, and 1 yellow, consider a successful outcome that could be either red or blue. Since the marbles in question are solid color and cannot be both red and blue at the same time, these events are mutually exclusive. Event A and event B are mutually exclusive if the occurrence of event A makes the occurrence of event B impossible. If the marble is chosen red, it cannot be blue. Okay, so what you're going to find in your examples is if you see the word, it's kind of like either or when you're talking about probability. What is the probability of getting a blue or red? The reason it would be considered mutually exclusive is because there are no marbles that are both blue and red. So if your events can be found in both categories, then it's not mutually exclusive. Let me show you with your examples. Okay, example 11.1e, okay? A pet store has 4 cats, 2 parrots, 6 dogs, and 1 snake for sale. And it wants to know, is buying a dog or a snake mutually exclusive? A dog or, here's that word or, snake. Is that mutually exclusive? So how do you answer this? This is what you ask yourself. Can a dog be found in the same category as a snake? No, it's either or, either a dog or a snake. So this one would definitely be mutually exclusive, okay? Now, if you look at example B, here is where it comes in. It says buying a cat or an animal with 4 legs. Okay. Here is the deal, okay? We're still using this word or, but you look at your events, you look at what it's asking about, okay? Cat or an animal that's with 4 legs. Does a cat have 4 legs? Yes. So these events are not mutually exclusive. It's not either a dog or a snake. It is a cat or an animal with 4 legs. And because a cat falls in both of these, your answer is not mutually exclusive. Now we're going to look at 11.1f. We are looking at the probability of events that are mutually exclusive, but it's compound, okay? It has like more than one thing it's asking for. All right, so if you look on page 499, 11.1f, it says, it gives you an example, a bag contains 12 solid colored dominoes, 8 red, 3 blue, and 1 yellow. What is the probability of selecting a red domino or a yellow domino at random? Okay, here we go. These 2 events are mutually exclusive, okay? It can't be both red and yellow, it's either or. All right, so you're going to have to determine the number of outcomes for each color and then simply add them together. So we're going to start, okay, what does it want? What successful outcomes are we looking for, okay? Well, it's asking us there are 8 reds, and there are also 1 yellow, okay? And we're looking for the probability of getting either one of those, okay? And there is, the total amount of dominoes is 12, okay? So, you add 8 plus 1, your reds and your yellows, to get 9. This is the amount of successful outcomes you can get that are either red or yellow. It's 9, okay? So that becomes, on your relative frequency formula, that becomes your numerator, okay? 9. There are 9 that are either red, 9 that are either red or yellow. And then you put that over your total just like we've been doing, so 9 over 12. Go ahead and divide 9 by 12 and you're going to get 0.75. That is the probability. And now we're going to look at example 11.1G. It says a local used car lot has an inventory space for 60 vehicles. 13 are trucks, 22 are minivans, and 25 are cars. What is the probability that a salesperson will sell either a car or a minivan? Round your answer 3 decimal places. Okay, so first of all, you have to identify your successful outcomes, okay? So, what does it ask for? Either a car or a minivan. It's mutually exclusive. Cars do not fall in the same category as minivan, okay? So, how many cars do you have? 25 cars. How many minivans? 22 minivans, okay? So, total, what are my successful outcomes? Well, 47, okay, that are either car or a minivan, okay? Now, this is my total successful outcomes. This is not the total amount of vehicles, okay? Does that make sense? All right, so these are my successful outcomes, okay? These are what goes over top of our total, okay? So use our relative frequency formula. You remember that? That's what we've been doing this whole time. And that is where you put successful outcomes over the total. And we have already figured out our successful outcomes, and that's 47. And our total, go back to your problem, is 60. And you do the same thing, simply divide 47 divided by 60, and your probability is 0.783. Now, how do you know if you got the wrong answer? Well, let me just go ahead and tell you, if you get anything that's negative, it's the wrong answer. If you get any number bigger than 1, it's the wrong answer, okay? So all of your answers should be decimals or fractions that are between 0 and 1. And that's example 11.1G.